So hi sir, this is Maulik from CACF section. So today I'm going to give a presentation on the subject data structures. So in the topic I choose this DFS in data structures. So let's see line by line. A comprehensive guide to understanding and implementing one of the most fundamental graph traversal algorithm in computer science. So here basically it is the graph traversal technique used in data structures for a graph. This is the basic of the DFS. So let's go to next slide. What is the depth first search? Depth first search is a traversal algorithm that explores as far as possible along each branch before backtracking. It uses a stack data structure either explicitly or through recursion to remember vertices to visit next node. DFS starts a root node and explores each branch completely before moving to the next branch, making it ideal for properly requiring exhaustive search or path finding. So here basically here this slide says that we used to represent DFS a stack. So in the stack we store each element one on another. So this is the main mechanism for the DFS algorithm. So before backtracking only, all nodes it will be visited. After uh, backtracking it will not work. Before backtracking only it should visit every child node of its parent node. So this is the overview of this slide. So next let's go to next slide. Core principles of DFS. Stack based approach. It used LIFO, last in first out structure to track vertices and enables deep exploration before backtracking. Visited tracking maintains a visited set to prevent infinite loops and redundant process of nodes. Recursive nature naturally implemented using recursion call stack and this traversal order. So basically here this whole slide says it follows the principle last in first out, means which the element which comes last it will go first. So for example we keep uh, for correction, for internal record correction we keep our books, but which book is being kept last, it will be corrected first because on the top it will be. So here stack also having an element called top. We can access the elements using the top only. So this is the core principles of DFS. Next let's go to next slide. So how does stack works step by step? So this slide says how the stack works. Initialize, explode adjacent, go deep, backtrack, complete. So just now I said it will initialize and every node it will visit. So this is the main point in this slide. So let's say what is this. Mark starting vertex as visitor and push it to the stack. So mark the first vertex as visitor and push it to the stack. Select an unvisited adjacent vertex and marking it is as a visited. Continue exploring deeper, always choosing an unvisited adjacent vertices. First backtrack when no unvisited adjacent vertices exit. So backtrack and continue. Process and no actually here whole slide says how the DFS works using the stack. This is the main idea of this stack using DFS. Let's go to next slide. So here implementation approaches, recursive implementation and iterative implementation. So this slide just says the code of the DFS. It's not important generally for understanding DFS, but it's important for writing an code, or for an interview they can ask write a code of for DFS, or in any external or internal they can ask write a program on DFS. So it's important for only that point, but generally we should know what is DFS. So see here there are two types of implementation. First one, clean leverages with call stack naturally backtracking. Second one, stack control over it used for avoiding recursion. This is iterative, that is recursive. So these both are the implementation approaches. So let's go to the next slide. Key applications of DFS. The key applications of DFS means pathfinding, connected components, cyclation detection, and the last one sorting, some sorting. Finding path between vertices and detecting whether a path exists. That means pathfinding. Connected component, identifying all components in an undirected graph for network analysis. Detecting cycles in directed or undirected graphs, crucial for dependency resolution. This cycle detection. And the last one, topological sorting, order vertices in a cyclic graphs for task scheduling and build systems. So these are the applications of stack, means where we use this DFS. So let's go to the another slide. So this slide says performance analysis. The performance analysis has been classified into different types. First one, time complexity. Second one, space complexity. Third one, stack depth. So here order O means order. So order of V plus is the time complexity. Order of V means space complexity. Order of H means stack depth. So these three are the different performance analysis of DFS algorithm. So let's go to the next slide. So last slide just says the difference between DFS and BFS. Generally DFS, BFS, the difference is BFS means it searches the node breadth-wise, means before backtracking it backtracks and search whole line, but in DFS it searches its whole into the depth, every node of its parent. It visits every node, but in BFS it will not visit any node, just it will search. So let's see here DFS versus BFS. When to choose? Choose DFS. Need to explore all possible paths. Memory is limited. Solution is likely to be far from find a solution that is acceptable. And when to choose BFS? You need the shortest path. Solution is likely close to the root. Graph is infinite depth. Find optimal solution matters. Level by level traversal. So these are the differences between BFS and the DFS. So I will conclude here my presentation by saying one conclusion, that DFS means depth first search algorithm. It is a topic in the data structures. Here we use the principle last in first out. So this is the main topic here. So I will conclude my presentation here. Thank you. Have a nice day.